So here in our dashboard view we have gauge or dial graphs for every RPP unit that's out in the data center. So here we have them labeled RPP 1A, 1B, 2A, 2B, and so on. And so this is really meant to be a visual representation of the percentage load that's on the individual unit. So the gauge graph is the overall unit, counting the load from all of the subpanels of the RPP. And these bar graphs over here indicate the load on each of the individual subpanels in the RPP. If we hover over with our mouse, we can see there's a little tooltip that shows what each bar graph is. So this one is the first subpanel, phase A load, phase B load, phase C in the second panel, and so on. And so this RPP showing here has two subpanels, and whereas this one down here has 4 subpanels. So here there's 12 graphs showing, one for each of the 3 phases on each of the 4 subpanels. If we click on the title or the name of the RPP here, this will bring up the circuit view for that RPP. And so here we have the live view of the current loads of each individual circuit. So here we have circuits 1 through 42 for the first subpanel in RPP 2A. We can also select here the different subpanels in each of the RPPs. Here we have them labeled CP3A through CP6A. So if we select a different subpanel, we can see the 42 circuits for that are for that subpanel. For each circuit, we have the circuit ID here. We have a description field if we choose to fill in a description for that circuit, and the load. So this is showing the current load. That is a live view of what the current draw is on that circuit right now. Again, if we hover over, we can actually see the real value, and this is the actual value in amps that the circuit is currently loaded at. So this one is 10.9 amps, and it's a 50 amp breaker. If we click on the circuit number, this will bring us to the historical view. So this shows up here at the top of the graph. We can say we're looking at CP4A, which is the name of the subpanel for that we're looking at, and circuit number 2. And if the circuit had a name or description, then that would show up here. Here we can see over the past just a very short while, we've been gathering data here that our load has varied a little bit, probably nothing more than what would be expected for this load. But here, if we hover over an individual point, a tooltip again will show up saying that on December 20th at 2:45 p.m. the load was 10.7. And the same is true for each of the individual points. And as we continue to gather data, this graph will grow. And you can look at more data points, obviously. Once the graph has grown to a particular size, the program will automatically summarize the data into older data sets. So the idea is that we don't want this graph to get too large before it becomes unusably complex or have too many data points on it. So up here we have a time frame selector, which allows us to go back to most recent, old, older, or oldest. In this case, we haven't been gathering data long enough for the other graphs to have any data on them. But once the most recent graph fills up, so to speak, then the other older and oldest graphs will start to populate.